We've already seen how Grignard and hydride reagents can react. Let's just take this time to add just a little nuance to our understanding of this. Remember what the Grignard reagent is. It has a nucleophilic carbon which reacts like a C-. So if I have methyl Grignard, right, that is H3C MgBr with a very powerful partial negative on the carbon, very powerful partial positive on the magnesium, roughly equivalent to or reacts like H3C minus with the MgBr plus as a positive counterion. So the actual substance is somewhere in between here. Remember back from your Gen Chem days that covalent and ionic are not totally separate things, right? There's a continuum between how much electron density is shared and how much has been transferred. So in this case, it lies pretty far towards the ionic side, but we can still draw it with a covalent-like bond there, as it's typically done. The covalent bond can just sort of be a abbreviation between two oppositely charged atoms next to each other, for instance. So what's interesting and what we haven't actually discussed yet is that the carbonyl becomes activated by that positive Mgx ion, right? What we can think of it as one of the lone pairs on the carbonyl oxygen gets donated towards the Mg plus there. That makes the carbon of the carbonyl an even more powerful electrophile. Okay, gives it even more of a positive charge. That will allow the C- to even more easily attack the carbonyl carbon, bringing the electrons up onto the oxygen, giving us an alkoxide, right? And look, here it is again. They drew this covalent bond, but that can be very similar to C, R, two bonds, O, a little more. I can show that pair of electrons on the oxygen, right? The difference is where one of these pairs of electrons is. Is it all the way on the oxygen? Is it shared between oxygen and magnesium? It's somewhere in between, right? So it's a very strongly polarized bond that's probably mostly ionic, but can be equally drawn as a single line like that. Okay? Both of these are two different ways of drawing that same alkoxide intermediate. Okay, so of course then in the second step, if we add water or acid, H3O plus works a little better to get the product soluble. Anyway, that gives us our alcohol. Look at the counterion here, right? If I added water, it's MgX-OH, right? If I added hydronium, it would be MgX plus. So the reduction of a carbonyl is the exact same mechanism. Just instead of a C-, we have an H-, right? That's a hydride. And in fact, if I use sodium borohydride, the sodium actually complexes with that oxygen to activate the carbon even more. But we got hydride attacking, we have an alkoxide, right? Just like we had up here, gets protonated, we have an alcohol. Look at how similar these products are, right? From the Grignard reaction, we have an alcohol with an additional R group. Okay? With carbonyl reduction, we have an alcohol with an additional H that's been attached.